Great, thanks so much. And thanks so much everyone in RSECon, all the kind volunteers. It's been an awesome time here. So my name is Nick Tierney. I work at the Kids Institute, which is based over in Western Australia, in Australia. And I currently live in Hobart, in Tasmania. So today's workshop, I want to talk about some ways to solve some things that come up in data analysis. And I think inherently we have some interactive and messy components to doing a data analysis. And one of the issues I find is that there's this sort of impulse to like rerun things a lot. If you're not sure if it's up to date, I better just rerun it from scratch. And months later, like, how did you do things? Like you come back to a project from like 6 months ago that you wrote, and you're like, I don't know how any of this works. I better just start from the top again because I'm not sure if anything's loaded or how anything works. And I think that as you think about data analysis, it deserves some inherent kind of structure. And there are a lot of different ways to structure things, and this is, sort of one of the wonders with how we manage our own folders and file systems. I'm not sure if you've had the joy of sort of opening up another person's laptop and seeing like their downloads folder, or just like how things are structured, and you're like, that's chaos, or like that's overly organized and that sort of thing. And there's a lot of ways you can organize a data analysis, and this is just one way. I think it's quite good. Another point I want to make today is that you're always collaborating with your future self. I think it's just something I heard, I think it was from Hadley Wickham, and I just think it's a really worthwhile thing to consider. So like, we want to be kind to our future selves, we want to set ourselves up for success. Targets is a way to manage the complexity that comes up in a data analysis, and I'll talk more about targets as the talk goes on, and about how I sort of think it's a bit of a mindset and a philosophy to approaching a data analysis. So I've got 3 goals for today. I want to convince you that the targets package is worth learning. I want to convince you that you can use it. And I want you to feel more confident in writing a function. The audience for today, just like a raise of hands, who uses R here? Okay, great, that's good. This is an R package. I still think that there would be, like, this whole approach is going to be within R. If you don't use R and you're curious about how it works, I still think there's something in it for today, but I just wanted to set that and understand sort of who the audience is here. And if I can get a raise of hands of anyone who's used the targets package before. Okay, great, all right, thank you, that's very helpful. So the way this is all going to work, so I've got all of this talk and this analysis here on GitHub at njtierney/gentle-intro-targets. This is going to be an entirely live coded thing, which is a little bit nerve-wracking. It feels a bit like a performance. I have like a script and everything. Yeah, there is no like, here's one I prepared earlier. I really wanted to demonstrate the process of like doing this live. And in doing so, I think that there are things that happen when you watch someone code. They do like a little keyboard shortcut that they might not have thought about or something, or they might do something in a different way to how you would, or it just might seem like there's a neat trick somewhere. So I really want to encourage you to ask questions throughout. Please feel free to interrupt. I know we have the Canopy system, and I have the notes here, but if you feel like there's like a little something like you just want to say right now in the room, I'll repeat the question for those who are here online, and also our kind volunteers have said that they will read out questions to me as they come up. But I just wanted to encourage you just to like have a hair trigger on like, oh, what was that? And I'll tell you more. Please ask questions throughout. Ask on Canopy for deeper questions. If you feel like there's something that's a bit more of a a longer question to explain, I think Canopy will be a good place for that. Great. Oh yeah, and so I'm going to do a data analysis. It's a little bit simplified. And I'm going to be asking throughout, and I want to put this on the slides here, it didn't quite fit, but what questions do you have, as opposed to do you have any questions? So I think I just really want to encourage you to ask questions. So this was not really designed as a follow along exercise. You're welcome to try, but I haven't designed it like that. I think you might be best served to observe and take notes and ask questions throughout. You are welcome to try and follow along, and I will be putting all of this up on GitHub. I'm going to challenge myself to try and do Git commits throughout as well to demonstrate each stage, but that might be aspirational, we'll see. And again, please ask questions. So today, we're going to be talking about the Penguins data set. So this is Palmer penguins. The Palmer penguins data set, which is produced by Alison Horst and Alison Hill, and it's made available by Dr. Kristen Gorman. So I just want to acknowledge those people first. It's this awesome data set of penguins in Antarctica. It has a similar kind of structure to the IRIS data set, if you've seen that before. And they've done a really good job with documentation and like telling the story of this, and also talking about the 3 different types of penguins in here. What they've also got that is really neat as well is that all of this data is actually based on a paper. So I think, hang on. Yeah, so this paper is called Sexual Dimorphism in Penguins. And so this is about like, can you predict, or like, can you look at the differences in sex in penguins based on other measurements? And so that's a bit of the inspiration that we're going to be using for today's analysis. We're going to do something similar, and we're going to build a logistic regression predicting sex based on the penguin bill dimensions. And I'm now going to start a timer, and I'm going to start the live coding demonstration. Okay, right. So we're going to start. First, is this text big enough for people? Can you see it okay? Awesome, how good is that? This is like the right size for me here too. So this is a win for everyone. So we've got, I'm going to start in a script, and then I'm going to move into a targets workflow. Great, first I'm going to not leave this as an untitled 1 tab. That's a very common habit of mine. I'm going to call this run me because it implies something similar to a readme, like you probably want to run this code here. I'm going to load a couple of libraries. We've got the tidyverse, we've got the Palmer penguins data set. I'm also going to load the visdat package, which is a package that I wrote. So let's start by looking at the penguins data here. So we can press Command Enter and see here we've got information on species, island, and bill length. And if I press Command and click, it'll actually open up a viewer, which is a really neat thing to know about. I actually ran the command view on penguins in our studio. So just to give a rough overview, I think this is nice to see. Okay, we've got species, island, information on the bill length and depth, flipper length and body mass, sex and year. And I see that there are some missing values here. So what I'm going to do is I'm going to run the vismiss function on that. Vismiss is from the visdat package, and this gives you an overview. It's like a heat map of the missingness in your data set. So what we can learn from this data viz, well, I'll just break it down first. We have like the rows here. So it's kind of like if you had a zoomed out kind of spreadsheet of your data. And then these are the columns. And I have here like a little percentage sign for how much missingness is in each of these here. And I see that overall I've got about 0.7% missing, and about 1% in a few variables, and 3% in sex. So overall, this isn't too alarming. There is some missing data we are going to have to deal with, but it's comforting to know that it's relatively low. And in an ideal world, I would then impute that data now, and then I continue the data analysis. But that takes a little bit longer. And what we're going to do is we're going to look at, I'm going to do an exploratory plot of the bill length and depth. So we're going to start with the penguins data. And if you haven't, so this is using the ggplot function from ggplot2 in the tidyverse. And on the x-axis, I'm going to put bill length in millimeters. And on the y-axis, I'm going to put bill depth in millimeters. I do it in this order because it's sort of the length and the depth of like a penguin's bill. And that's like a useful way to think about length along the x-axis. And I'm just going to do this with some points. We're mostly interested in, so we see that there's like probably some clustering here. We're interested in looking at this coloring by sex. I'm going to do that, and I see we've got male, female, and NA values. But we still have those groups there, so I think what I'm going to do is facet this by species. And so we can sort of see that there's these 3 kind of different groups. And we have like a sort of a clearish pattern about, generally it looks like males have longer and deeper bills than the female penguins in each of these species. So this is just a little bit of exploratory data viz. I'm going to do one more thing that I think is important enough to make it in here. I'm going to use the color space package, And so for our colorblind friends here, I'm going to use a colorblind friendly scale. So I'm going to use scale color, and then it has this cool syntax. We're using a discrete variable here, so write discrete and then qualitative. And this will now just give us a slightly different color scale. It's actually blocked out the NAs, so we can use na.value and say this is black. Again, this is also kind of interesting. I think it more clearly shows some of the missing values. Missing values is an area of research that I did a lot in my postdocs. This is something I care about. And yeah, just out of interest, it looks like the chin strap penguins don't have any missing data, but there's some in the Adelie and the Gentoo where they have missing values for sex. Okay, so it's done. What questions have people got so far? Anything coming up? That's all right. All right. Okay, now let's build a simple, I say simple, let's build a logistic regression. So I'm going to call this penguins GLM. I'm going to use the GLM function, passing a formula. We're going to predict sex with bill length, millimeters, plus bill depth in millimeters. And then family here, we're going to say this is a binomial. So this gives us, this is what makes it a logistic regression. And the data is going to be penguins. So we fit that model. And now if we look at this here, print this out. All right, we've got some coefficients and some things here. So let me just make sure I'm on track. Good. I'm just going to quickly check to make sure that we're getting sensible predictions here. So I'm going to do predict on penguins GLM. And that should give us out some values. If I do summary on that, I just want to know like what's the min and max. Okay, an important point here. So because this is a logistic regression, we're getting our outputs on a different scale. So we can use type equals response with prediction. So now this gives us the probability of male or female, and I'm actually not sure which one it's going to code here. Because if we look at our data for penguins here, sex is coded as text as male, female. And so I'm not sure, like probability of male or female, like how do I know which one it's used? That's like a little bit unnerving, perhaps. Because that's like an important thing. So what I want to do now is I want to put, I'm going to put the predictions alongside the data. And I can do that with the Broom package. What we can do is we can use the augment function. This will add along like a bunch of model information for each row. So it'll look something like this. I'm going to say augmented penguins gets augment penguins GLM. And then we have type predict equals response. So that's how we ensure we get those values on the correct scale, or the scale that we want. And again, if I command and click on augmented penguins, we've got information on sex and bill length. And now what I'm going to do to try and understand this is I'm going to use ggplot to plot this data here. And I'm going to say plotting sex against dot fitted, and then use geonPoint. We get a bunch of values there. It's a little bit tricky to see. It probably looks like female is coded as 0 and male is 1. If we use geonBoxPlot, that'll give us a better indication. Okay, good. So this is actually the wrong way around. And haha, this is my plan all along as part of the live coding demonstration. So the problem here is that in the paper, they actually had, yes. Okay, so what I'm going to need to do now is I'm going to need to update the data. And I need to update the data and then decide what to do from here, right? And this is, I think, the point I want to illustrate here is that this is something that happens in your data analysis. It's an iterative thing. So I could say, let's create penguins modeling. And I'm going to say, take the penguins data, and then using pipe, I'm going to say, let's create a new variable called isFemale. And just to be super explicit, so I'm really sure, I'm going to say, if else sex equals female. If this is true, 1. If this is false, 0. So I'm like really clear on that this is definitely going to be coded as 1 for female and 0 otherwise. So now we do that, and then I probably actually, well, I don't want to repeat all that code. I probably want to put that up here now that I think about it. So, and then this sort of presents a problem because now I need to make sure that all of my later references to penguins are going to be updated. This is just sort of a relatively common, I think, problem in a data analysis. But let's make sure we do that. So I'm going to put that in here. I'm going to update this plot. I'm not going to update that plot just for a reason. But, and then I'm going to look at, actually it won't make any difference, that's good. And then I'm going to update our model. And I think that should run everything. But I'm like a little bit nervous because like when you're live coding, you use like 20% less of your brain. And I'm not sure if anyone here can find a mistake, but we'll see, I don't know. Let's highlight all the code and run it all again, and fingers crossed this works, right? I think that worked, that was good. So what we're going to do is we're going to introduce using targets for this. And just because I said I would, I'm going to commit this. So I'm going to say this commit will demonstrate a script-based workflow. I like to finish my commit messages with the sentence, this commit will, and then say the thing that it hopefully is trying to do. And then sometimes I also like to add a rocket emoji because I think that's fun and it makes me happy when I look at my commits later. So I'm going to push that. And great, so now I'm going to start this process of turning this into a targets pipeline. The first thing I'm going to do is I'm going to rename this file _targets, which is what you need. This is like the file that is detected in a targets pipeline. So I'm going to talk through these things as I go, and then hopefully this will all click and make a bit more sense. I'm going to create an empty list. So all of this stuff is going to go in a list. And then for each of these steps in this analysis, I'm going to wrap this in tar target. And what this takes is, I'm going to delete this line here. This code here, this is a target. So this is the modeling bit on the left-hand side of the assignment arrow, and on the right-hand side is the code. So I'm going to put this inside tar target. I'm going to get rid of the assignment, and the code is going to look like this. If I highlight all my code and I press Command I, it re-indents it, which is just a nice thing. This helps me look at my code a bit better. So this is a target. This is penguins modeling, and this is like the target output, and then this is the code that generates that target. So we're going to continue this process. It'll just take a moment. Tar target, I'm going to call this penguins vismiss, and it's going to take in this code. And then I'm going to call this tar target penguin bills. And then it's going to take in this here. And I'm going to re-indent. It helps me look at things a bit better. Tar target penguins GLM. Okay, good. I don't think I need to care about that project thing anymore because that was like a bit of an exploratory bit. But I do want this bit here with the augmented data. And I'm going to move all my library calls up to the top, so they're all sort of in a little home together where they can all hang out and talk about loud microphone noises. Okay, so I'm going to do this. Augmented penguins gets that, and then this is going to be. So this is, I think, something that is an important point. So like I've been deleting a couple of things here, and I think that sometimes I've heard this called old lettuce. Like old lettuce would be if I like just commented this out and just kind of left it there and just kind of hoped that I'd forget about it. I'm just going to delete it and be brave because like I know why I looked at that, and I don't think that serves an important point right now. But I think it's just worthwhile noting that. Okay, great. So we wrap things in tar target, and we have our targets pipeline. It's in this _targets.r folder. We have our packages at the top. We've got our list of targets. I better load the targets package actually. Okay, great. So now what I'm going to do is I'm going to run tar make. It's called tar make because targets is inspired by these make-like pipelines. Just a raise of hands of people who've heard of make, like the library. Okay, that's really good. So this referring to things as targets is like a common thing when you're talking about make as well. So we're going to run tar make, and then we're going to watch the console, and a bunch of stuff is going to happen, and we'll probably find an error, and we'll be in it together. Yeah, all right. So this is an error, and what does this say? Could not find function tar. Oh, okay, right, this is a really good one. So what's happened here, if we notice up here, this is not saved yet, and if I just save it, because it didn't have this library at targets call here, and then if I run tar make again, all right, so that's the error. Anyway, it's like a really common one for me. So we see it has a bunch of information. It says like dispatch this target, completed this target, and it gives you the information how long it took in seconds, which is really cool, I think. And then if we run tar make again, it goes through, and what it does, like what's happening here is it opens a fresh R session, and it works out the way to run all this code. So we know like reliably this is going to be run from scratch again. This is similar to how you might run things, say like in an R Markdown document or a Cordo document. It's starting up a fresh session of R, and then it's running all the code from the start to the finish. Except what it's doing is this really clever way of determining dependencies. And we can see this with this function tar viz network. Come on. There we go. Okay, great. And so what this is this is a beautiful dependency graph. We see here that Penguin's modeling is the thing that flows into all of these other steps here. What's really cool is if we decide, because we actually had some missing data earlier, so what I should do, and what I'm just going to do right now to illustrate this, is I'm going to drop all the missing values. And I'm going to update that code there. And then if we run tar viz network again, it's going to find these dependencies. And we now see that because I've updated Penguin's modeling, all of these other bits are out of date there. So it's actually going to run everything that depends on that target for you. So if we run tar make again, it's going to rerun everything from scratch, and we can check that that's worked with tar viz network. It's now turned this green color. Okay, I've got a couple more points to make, but I wanted to pause and ask what questions people might have here about this. Anything coming to mind? Yes.
Do you want me to say it again?
Yeah, you're right.
So when you run tar make, all of the successful outputs, whether they're skipped or completed or errored, which didn't happen in this case, are all red. So if you want to quickly skim through and see has it worked or not, your initial reaction is, shit, they're all red.
That's a really good point. I think what is comforting is if you run tar make again, you get tick marks, which is good. But like we saw earlier, when I had an error, there was just a lot of stuff here. So it is interesting that there isn't. I think it's because it's running it in a separate R session. Because normally, if you load something like the tidyverse here, see how all of this is normally green and stuff. So I'm not really sure, but it's a good point. I will say that this package is maintained by Will Lando, and I might actually just write a note to him about this because Will Lando, I think, is the most responsive R package maintainer I've ever come across. So he's so he will probably be yeah, we should do something about that. But yeah, good point. I hear you. I get that. So now I want to talk about where did all this stuff go? Where does it live? So if we look back at our files here, we've got this new file. Well, I guess I didn't show the directory before, but you can trust me, or you can even trust Git and see that there is this _targets folder here. And this contains a bunch of information. The thing I want to focus on is objects. This is all of our objects. This is where the data is stored. And this is, I think, a bit of a tension sometimes. When you're doing a data analysis, we've constructed this lovely pipeline and everything's connected to each other, and that's great. But if I want to look at this object now and say I've just restarted my R session, so I don't have access to the things that I did in the previous session. If I want to look at it and I just like copy that into the console, like it doesn't know how to get it, and it's like, well, how do I read it in? So there are two functions. There's tar load, and you can pass that this object here, and then it loads it. Oh, it can't find it because I need to have targets loaded as a library. So I'll just run that again, tar load, and then the target you care about. And now we have penguins modeling here. That's good. What's better is that there's a bunch of keyboard shortcuts that I think are really worthwhile knowing about. So in targets, we've got load target at cursor and make target at cursor. I've set these to something a little bit involved, but it just helps me not accidentally do this. But if I put my cursor here, over here, and I do my keyboard shortcut, it'll load it into the environment. And I think that is like a worthwhile thing to know about to help, because I think that there's a bunch of stuff like this. There's a bunch of tension and friction that you encounter in a data analysis, and keyboard shortcuts help you sort of more easily flow through that. And also, similarly, I can run the keyboard shortcut for making that. So if I have my cursor there, I can do this and it'll make that specific thing. So that's also something that you can do. If you do tar make, by default, it'll make all of them, but you can also just make a specific target, which is kind of handy because you might not want to run the whole pipeline. Like you might just want to do one specific part, and that might save you a bit of time. It just occurred to me now, this actually might be like a bit of a hack. So I think if I do tar load just by itself, I wonder if this is actually going to load all of my targets. It doesn't, okay. What you can do, this is also kind of wild, you can do stuff like, so there's this whole syntax from this package called tidy select. You can do starts with, and I could write like penguins in here, because I've happened to write a lot of penguin stuff here. And then it'll load all the targets that start with that name. Thank you. And yeah, keyboard shortcuts, changes in the code. Okay, great. The next thing I want to talk about is we've got our targets and we've written them here with our target and then our code. And I don't really think that this is really going to scale super well if you, say, have a huge amount of data analysis that you're going to do. And this is why I think we should write functions. I have a lot of, I think functions are hard to teach, and I think they're hard to get good at. I think they're really worthwhile learning. The thing that I think is really important about functions, which I've written here, it's just escaped my mind, is that they help manage complexity. Yeah, that's it, right. So writing a function here is going to manage this complexity, and it's going to more clearly express our intent. So what I'm going to write here is a new function called prepare penguins, which is also a funny thing to say. Okay, and so I'm going to put that there. And what I'm going to do, so now I would probably need to create an R folder somewhere and then sort that out. What I'm actually going to do, there's this really awesome package called fnmate by Miles McBain. It's going to turn on so you can see my keyboard shortcuts. This should hopefully show up there. Great. So I'm going to do my keyboard shortcut while my cursor is over here, which is Option Shift Command F. And we see here a little note. It says fnmate wrote this. So now if I press Command and click, which is how we can sort of go to function definition, it's created this stub of a function for me, which is really neat. So now I'm just going to copy this code in here. And I'm going to turn off my keyboard shortcut shower. I'm going to put this code in here. Great. So I'll just show you this code. GitHub, Miles McBain, fnmate. So this is where you can find it. I have a link in the slides as well. And so the way that I set that was in my keyboard shortcuts after I installed that there. Function create function definition file is what that was called. He has instructions on his GitHub repo as well. This is a bit of a game-changing thing, I think. So here I'm going to say that this plot here, I'm going to say this is, actually I'm going to just rename this. I'm going to call this plot bills. I like to start my plots with the plot keyword because it helps me load them later with targets. And I'm going to call this GG bills. And input is penguins modeling. We don't have any other things I'm going to change here, so I'm going to leave it as that. And then I'm going to create a new function, copy this code in here, and go to GG bills. Put that in. And then I'm going to call this fit GLM. And it's going to take in penguins modeling. And then I'm going to copy that. Well, it's a bit of a risky move doing a copy on the fly, but and then do this. Great. Cool, and then that augment there is like, I'll leave that as is. And I want to pause here. We've written a bunch of functions. I think it's saved us a bit of time. We've reduced that friction. And this isn't just about look at how few lines of code I can write now. It's about expressing your intent. Naming functions is hard and it takes practice. I like having this sort of rough idea of my functions that do stuff with ggplot start with gg. My targets that receive them start with plot. Fit GLM, that's a bit generic, but we'll stick with it for the workshop. But it's nice to write things out like this. What's also really cool is that as you start a data analysis like this, you can start to outline your entire pipeline with all these functions that don't even exist yet. So you can write out, I'm going to read in some data and then I'm going to do some modeling, and then I'm probably going to interrogate those models later, so I'll write some interrogation steps. That's going to take in this other thing that doesn't exist yet. And the idea of stepping through that whole sort of overview process, I think is worthwhile getting good at. Okay, cool. So now we've done this. Let's run tar make and we'll see what happens. Okay, we get an error and it can't find the function prepare prepare penguins. That's because we need to tell it to source them. Instead of writing source r/ all of these things, what targets has is it has this little handy function called tar source that it knows to go to your R directory and it'll find that there. So now I'm going to run tar make again. Oh, another error. This is good. Good debugging. Penguins modeling not found. Oh, that's a bit of a worry. 21. That one there.
Yeah, there's a D where it should be penguin.
Oh, bless your cotton socks. Thank you so much. All right, let's run tar make again. Oh, hang on. Do I save it? We've got another one. Penguins modeling. Oh, you know what it is? It's correct there, but it takes in the same thing, so it's looking for penguin. Anyway, all right. Tar make.
And on 6,
Line 6. Ah, good. Good catch. So that's actually another thing that, so thank you, Anna, and I'm not sure your name yet, but thank you very much for helping with that. So fnmake will also generate this stub of documentation. It'll try and find your name and work out the thing there, which is handy if you're working on a project together. This also implies that you're going to have one file per function, which is, I think, a nice way to work. It helps to reduce merge conflict errors when you're working in a team. It is a bit of a different approach, because then you can end up with hundreds of files. I think it's worth it. I think I'm actually pretty much out of time. So I might just stop there. I think I've got about 5 minutes left. Is that about right? 2 minutes. Cool, I think that's all of the main points there. One thing I will introduce is another package called Tarka types. What this gives us is a way to do stuff, say, for example, if I want to create a Quarto document that I can call explore, I'm going to call it eda/explore.qmd. This is how you can also like render like a document. Like you might have a bunch of targets that fall into this document at the end of things. If you'll just let me briefly create this here. Explore, delete all that. I can write library targets, and I can do tar load, penguins, modeling, and also penguins. Oh gosh, penguins, GLM. And save this inside of EDA and call it explore. Oof, okay. Now if we do tar viz network, we have all of this stuff here, and we see that it knows that this document depends on some targets because it's looked inside here and it's found that I've called tar load in here. So this is a little bit different, but this is about separating out your sort of endpoints. Like if you're doing a bunch of heavy lifting and modeling and stuff, you don't want to necessarily run that in your Cordo or your R Markdown document. Even though it has caching and stuff built in, it's not necessarily like a reliable way to ensure that all that stuff is run. It's nice to separate your document preparation from your heavy modeling. So I realize I'm probably about at time now. I might just jump to the end of the slides here. Man, this like time moves quickly. So good functions help you manage complexity, explain and express ideas. They can be individually reasoned with. They do take iteration. And planning out functions like this in a targets pipeline, I think, helps you plan out your intent. I really think the fnmate keyboard shortcut is worthwhile using to help you sort of smooth out that friction. I think that no problem is too small for targets, because the number of times you start on a data analysis and you say, oh, just this once or just this one time, I'm going to do it simply. I think it's worthwhile planning things out, and you'll get a lot of benefits. There's also a whole other package that I didn't quite get time to talk through, called T-Flow, which is also by Miles McBain, that helps you with setting up this infrastructure as well. Some things I might not have gotten to. Yeah, Nick. Okay. I want to thank Will Lando, who's the creator of Targets, Miles McBain for writing these packages and being a very helpful person, Nick Golding, my employer at Telethon Kids, and Eric Scott, who's also just a good source of Targets wisdom. I've got some resources here on how to learn Targets and where to go to learn more, and I might just stop there and say thank you very much.
Okay, thank you very much, Nick. That was interesting and very brave doing some live coding. Thank you everyone for some live debugging. We do have some questions on Canopy. I'll just get them up on the screen. Hopefully. Yeah.
Does Targets notice changes in data? It does. So what you can do is a thing. You could write tar file, and I could say new penguins. Oh, you can't see my. Oh, of course, they unplugged it. Thank you. No, you're totally fine. So there is a way to do that with a thing called tar file, yeah. So I started live coding again, but then. Can a large workload be built by having multiple target files, like building blocks? Can you tell me more about that question? The person might not be in the room, that's okay. So you can use files in there. So you could have like a bunch of CSVs or Parquet files, or even like a database or something, and you can tell it to watch that. And then it'll watch that file location to see if anything changes, and if it does, then it'll trigger the appropriate downstream updates from that. How do you interactively debug a target's pipeline, step through each part? That is, so they have a really good set of ways to work through that. There's a thing called tar workspace that allows you to basically jump into the definition file. So like to where a bug happened. And yeah, that is really worthwhile using in learning. It actually doesn't take too long to set up. I was hoping to get through to that today, but I might have to just, I was a bit aspirational in my live coding. But yeah, there is a way to do that. How do you structure targets to output many things from one function? A folder of 10 PNG files. Yep, great. So what you can do there is you can use, so there's tar file, and then there's also tar files. So you can output, say, for example, if you were to write a bunch of data sets or a bunch of plots as like an image, you can have a function that does that, and then its output will be a bunch of paths. So it knows to look for that path as the output of the function, which is a bit of a tricky thing because it's like, how do you manage how a function deals with side effects? Like if you make a plot, that is a side effect. So you have to make sure that the function that does the plotting does the side effect, but produces a list of the files that it outputs. So that's also its output, where those files are going.
Okay.
Yeah.
Thank you very much, Nick. I think we're going to
Yeah, no, that's
so
totally
that we
fine.
can
Thank you.
do the handover to the next session. Another round of applause for Nick, please. Thank you.